let's talk about the 2015 JMC question 1 to 15. All right, so that's going to be the first half of this paper. And well, I would say that this half paper is pretty easy as well, but slightly harder than the 2014 half, but still pretty easy. So let's take a look at how we can finish these questions easily, okay? So this is question 1. Wow. So definitely this question 1, well, if you have been following my sessions, you will see that this is got to be a numbers and operations question. And let's say it's about the addition and subtraction, all right? Addition and subtraction. All right, so it's asking you which of these following calculation gives the largest number or the largest answer. Well, you can see that all the numbers used in the 5 options given are the same, right? We are using 1, 2, 3, and 4. So it means that, well, whichever calculation has the least value taken away, it's got to be having the largest answer. So you can see that the first calculation is taking away the 2. The second one is taking away the 3. The third one is taking away the 4. The fourth one is taking away 7 altogether. The fifth one taking away 5 altogether. So in the end, you can see that the option A has got the least number taken away, which means that it is going to give you the largest answer. So that's it for question 1. Easy, isn't it? All right, so now let's take a look at question 2. Question 2. So this is a word problem. This is a word problem related to time calculation. So let's say it's a time problem, okay? So it says that it has just turned 22 o'clock and 22 minutes. So 22 past 22. How many minutes are there until midnight? We know that midnight is 0 o'clock. Or we can also say that it is 24 o'clock, right? Because we know there are 24 hours in a day. So essentially, we just need to calculate how many minutes there are from 22 to 23 o'clock, and then to 0 o'clock. We know that a whole o'clock has got 60 minutes. And if I want to know how many minutes are there from 22 to 23 o'clock, I just need to take away 22 from 60. That's how many minutes it has left in the hour between 10 to 11 p.m., right? So 60 take away 22, that's giving us 38. So that's going to be 38 minutes right there. So altogether we have 38 adding 60, which makes 98 minutes. All right, so the answer is going to be 98. Okay, so that's for question 2. Now let's take a look at question 3. I would say that again, it is a number and operations problem. And this time it's about fractions, or of course you can also say that it's about division, because fractions are essentially just division, but it is written in the form of fractions, so let's say it is fractions, all right? So we have 1, 2, 3, 4, 5 over 1 adding 2, adding 3, adding 4, adding 5. And that's going to be equal to, if you're just calculating this part, it's going to be equal to 1, 2, 3, 4, 5 over 15, which means that it is 1, 2, 3, 4, 5 divided by 15. So you can either make an estimation according to your experience, or of course you can just properly do the division, and then you will get that the answer is around 800. and to be exact, it's going to be 823 because that's the only option in its hundreds, right? So that's what we have. That's what we have. Definitely, I would encourage using, estimation in this problem. Say 15 times 800 is 12,000, right? So 12,345 divided by 15 is just a little bit more than that. So it's in its 800s. So that's how we can get the answer, okay? And for the next problem, question 4. All right, so this is another numbers and operations problem. And I believe you might have seen these kinds of questions in your 11 plus before, if you have done 11 plus. So it is the summation tower, which means that each two numbers down the bottom is the sum of the number on top. Like each new number down the bottom makes a sum, and that sum is the number on top. All right. So, well, the top number is already given, and we want to find the number in the bottom, which means that we can just do the inverse calculation, top down. So the first box we're looking at, it's going here. So we should look at this box because we can just do 105 take away 47 to find out that it's 58, right? And knowing that this is 58, it's easy for us to find the middle box right there. So that's the second step, finding the middle box. That's going to be 58 take away 31, which we can find that it's 27. After knowing the middle box, we can find the box on the right. So 47 take away 27 is 20. Knowing this box is 20, we can move on to the bottom one. 20 take away 13, that's 7. And now we know that x and this box makes 7 altogether. So we just need to find the value of this box, which is 13 take away 9, that is 4. So now finally we know that x adding 4 is 7, which means that x is 3, right? 7 take away 4, that's 3. So the answer is going to be 3. Okay, so the first 4 questions are just gone like that. And the fifth one, so the fifth one is a very typical fraction problem. So this time I won't say that it is numbers and operations because you would need to understand what it means by the question. So I would say that I would classify this question as a word problem, even though it doesn't really have a story as the background of it. But I would say that it is a word problem with fractions. So it's now telling you that the difference between a third of a certain number and a quarter of the same number is 3. So how would you express the difference between a third and a quarter as a fraction? We just do a third, take away a quarter, right? We know a quarter is smaller than a third, so that's what we can do. And it's going to be 4 twelfths, take away 3 twelfths. And that's going to be a 12th. So the difference between a third and a quarter is a 12th. Which means that if the difference is 3, 3 is a 12th of that number. So what is the number? Well, if I know the part and the fraction, I just divide the part by the fraction to find the whole. So we can divide 3 by a 12th, and that's going to be equal to 3 multiplying the reciprocal of it, which is 12, and that's 36. All right, so the answer is B for this question. Just like that. Please make sure you know how to calculate fractions, all right? This is kind of important, especially if you're already in year 7. There's no excuse that you don't need, you don't know how to calculate fractions at all. And then for the 6th question, it will be a geometry question, and it is going to be on angles. So to be specific, we can say that this question is on the interior and exterior angles. Of course, we can just use the interior angle sum of triangles to find the answer. But that's needing 3 steps, which is I need to find out what is this angle, what is this angle, and finally find x. So there is a quicker way which we can use only 2 steps to find x. So first of all, we can try to find angle A. Alright, so angle A is going to be 180 degrees, take away 110 degrees, because we know that the angle sum on a straight line is equal to 180 degrees, right? So removing 110, we get A equals 70 degrees. Now, the next step is whenever you have 2 interior angles and 1 exterior angle of the remaining interior angle, we can say that the exterior angle of a triangle is equal to the sum of the 2 non-adjacent angles. That's really a thing, okay? And that is because if you can see this angle, let's name it B, all right? So A adding B adding X is equal to B adding 120. So cancelling out the B on both sides, A adding X equals 120. That's where it's coming from, because both of them are going to be 180 degrees, right? So this is what we're doing. A adding X is 120 degrees, and that's because the exterior angle of a triangle is equal to the sum of non-adjacent interior angles. Okay, that's why. So we know that A is 70, which means 70 adding X is 120. So X is going to be 50. All right, so the answer is 50. Does it make sense? Okay, so let's move on to question number 7. So I would say that this is really a mind-blowing question, because I can't believe how easy it is, even though it's a little bit confusing what it means. Well, it literally says that the question is telling you that the product of 1, 2, 3, 4, 5, 6, 7, 8, 9 times 8 is very, very similar to the number 9, 8, 7, 6, 5, 4, 3, 2, 1. But then 2 of the digits are swapped. So we just need to find out which 2 digits are swapped. And if you're just thinking about there's any, like hard ways of doing it, forget about it. You can just simply do the multiplication to find out, right? And once you started doing it, you will realize that 1, 2, 3, 4, 5, 6, 7, 8, 9 multiplied by 8. So 8 times 9 is 72, carry over 7. 8 times 8 is 64, adding 7, that's 71. So it's going to end with 1 and 2 instead of 2 and 1. Which means that those are the 2 digits that are swapped. So the digit sum is definitely going to be 1 adding 2, that is 3. Right? So the answer is 3. And for this question, I would classify it as numbers and operations. Just simply multiplication. So if you're thinking about any difficult theories to solve this question, that is not necessary. You just need to try it out. That's all. Okay? And for the eighth question, so this one is interesting. I would say that this one is the remainder problems in number theory. So, first of all, it says that it has to have the same remainder when it is divided by 2 as when it is divided by 3. So the easiest approach is, of course, dividing each of these numbers by 2 and then by 3 to see if they have got the same remainder, right? That's something which all of you can definitely do. Well, like if you want to use a little bit of logic in this question instead of, like just going into it and calculating it, even though it's not much easier, but I'm still offering you with this approach such that if the numbers get more complicated next time, you will still have a way to solve it. Yeah? So first of all, we can see that anything divided by 2 has a remainder of 0 or 1, right? So that is a bad 0 written. Okay. So 0 or 1, anything divided by 2. And you can see that all the options given are odd numbers, which means that definitely the remainder is going to be 1 instead of 0. So we just need to find out which of them has a remainder 1 when divided by 3. So this is like remainder 0, remainder 2, remainder 1. So we know that this is all dividing by 3, okay? We know that it's going to be 7. That's how we know. That's how we know it. Okay? So, yeah. If you don't believe me, you can carry on with 9. So this is having a remainder of 0. This is having a remainder of 2. So 7 is the only one that fits the requirement, which is it has remainder 1 when divided by both 2 and 3. And then let's take a look at question 9, all right? So question 9 is a word problem with speed, distance, and time. So SDT, okay? Speed, distance, and time. So it says that a 63-year-old man has rode blah, 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 blah. And in total, he has gone 25,048 miles. So that's the distance. And that rowing machine is when she received it, when he received it for his 50th birthday. So what is the time that has passed? Because we are looking for the speed, right? How many miles per year? That's the speed. So if I want to know the speed, I can just do it by distance divided by time. So what is the time we are finding here? It is 63 take away 50, which is 13 years. So the speed is going to be the distance over time, which is 25048 over 13. And if we want to make a rough estimation for that, well, you can look at the options that are given. They are pretty much wide apart, right? So let's think about how many times is 25 out of 13. It's roughly about 2 times, right? So we can say that it's around 26,000 over 13, which is equal to 2,000, right? Because if it is 1,000, then it's going to be something like 13,000, 14,000, something like that. But it's 25,000 now, so it's much, much closer to 2,000 than to 1,000, which is why the answer is 2,000. Okay, and that's for question 9. All right, so let's take a look at question 10 now. So question 10 is about filling in the operations. Well, I would classify this as definitely an optimization problem in miscellany. Because we want to find the largest value of all the expressions that can be obtained in this way, right? So we are filling in additional multiplication into these boxes. So we just need to think about which of addition or multiplication is going to give us a larger outcome. We can see that both of them will increase the size of the numbers when we are operating it, right? If they are all positive integers, of course. So if I'm adding or multiplying positive integers together, they are always going to go larger. But then multiplication is going to amplify the numbers, the value of the numbers, much greater than addition, which means that we prefer using multiplication. With one exception, when we are just multiplying 1 to any number. When we are multiplying 1 to any number, it is itself, which means that it won't get any larger, right? So that's the reason why we are leaving the 1 out, finding the multiple of 2, 3, 4 first. And 2 times 3 times 4 is going to be 24. So if we are just multiplying that to 1, it's going to be the same. But now we want to make it as large as possible. So that's the reason why instead of multiplying 1, we need to add 1 there. So 24 adding 1, that's 25. And you can see that that's the maximum option among all the 5, which means that as long as you get the maximum option correctly, you don't need to try any other ways, because that's definitely going to be the largest. Well, so that's one good thing about the multiple choice questions.